Okay, so here is some chapter 4 exam questions, which is graph sketching and involves applying your graph transformation skills. So part A, we've got a sketch of this curve y equals fx. The curve passes through the point 0, 3 and 4, 0 and touches the x-axis at the point 1, 0. So what is this? This is a translation. We do the opposites inside, so it will be 1 to the left, because it's a -1, so left. So we just need to re-sketch that graph. Alright, A here. So this 1, 0 will go to 0, 0. And that will be 3, that's 0, 0, and that should get you your 3 out of 3 marks. Right, let's do B over here. So that is a stretch to the y axis, it's outside the bracket. So we multiply all the y coordinates multiplied by 2. So it's just a sketch, y coordinates multiplied by 2. So that will be 6 y0 here, y0 here, so it will stay the same. That's 1, 0. You can say that's 4 or 4, 0. That will get you your 3 marks. Right, remember this is inside. Impacts or effects. The x coordinate, we know it's the opposite on the inside. So that means if it's a half there, it means times 2, so times 2 to the x coordinate. So C, let's look, x times 2 here will be 2, 0, that will be 8, 0, that will still the same, stay the same as 0, 3. You could just write 3 here, or 0, 3. And that will get you your 3 marks. Right, so let's have a look at this question here. Do have a read of it. We have the curve of y equals 3 over x. On a separate diagram, sketch the curve of equation 3 over x plus 2 where x is not equal to. Showing the coordinates of any point at which the curve crosses the coordinate axis, so obviously that's y-intercept and x-intercept. Not sure why x can't equal 2 here, because we will get 3 over 4. I'm sure they mean -2, but anyway, let's just draw the sketch of it. So a sketch means a sketch. Now we know this looks like this, so imagine if f of x, this means f of x equals 3 over x. So to get this equation here, it must be 3 over f of x plus 2, which is going to equal 3 over x plus 2. So this we can see is a translation to the left, 2. So we just need to bring all that across 2. So your sketch will look something like this. And remember the isotype in the past would be here. But it's all moved left 2, so it's moved left 2. So this will all move left 2. So it'd be something like that, where minus 2 would be here. That's one isotope. And you'll still have y equals 0 as a isotope because it's moving. So that will still be the isotope, and that would be perfect. But it says showing the coordinates of any point at which a curve crosses the coordinate axis. So when y equals 0, you get 3 over x plus 2. Now that's not going to cross because we multiply by x plus 2, and that's not going to touch. We know the isotope is at y. So that's not going to touch. But when x equals 0, y is going to equal 3 over 2. So this coordinate here is 0, 3 over 2. Or mark here 3 over 2. And that will get you your 3 out of 3 marks. Write down the equation of the isotopes on the curve in part A. Well, just told you that by working it out. So isotopes are x equals minus 2 and y equals 0. Wonderful. You must understand reciprocal graphs and transforming them because these seem to be the most frequent ones that appear in my recent memory. We'll have a read of this question. We've got this point, 1a, lies on the curve with this equation. Find the value of a. And we need to sketch these curves eventually. Well, because you've got this coordinate, 1, you've got the x equals 1. Just substitute that in. So 1 plus 1 squared times 2 minus 1, which equals 2 squared times 1. That equals 4. So a equals 4. Sketch these curves, sketch that curve. So that means we're going to have a root at x equals minus 1, and because of that squared it's repeated, and we've got another root at x equals 2. Now that squared times x is, this becomes, if you multiply it out, a negative cubic, so we know it's going to be that shape. It does just say sketch, so let's sketch that down here, part BI. So, just finishing this question off, how did I get this point 2 here? Well, you have to think, when x equals 0, we're going to get here 1 squared times 2, which equals 2. Right, we just substitute into here. We know it's this shape that I've said before. This must be repeated, so it would make sense that this bit will be here. Now, does this turn right down here or continue going up? Well, if we think, let x equals 1, halfway we're going to get 2 squared times 1, which equals 4, which will be up here somewhere. So the sketch is something like that. That will be enough to get you your marks. So, you know, do substitute in points just so you get your sketch and get your full marks for it, because it's not worth it losing a mark when you can just do a bit of substitution to get an idea. Right, part 2, we know that's a reciprocal graph, so y can't equal 0 and x can't equal 0, because we can't get this value here to 0. So, if I was to draw that on the same graph, just like a normal reciprocal graph, doing something like that is fine. And C, with reference to your diagram in part B, state the number of real solutions to the equation. So I've written here, there's two intersections, hence two roots, because they're asking us to solve when there's this equation from above equals 2 over x. We can see it here. So two intersections, hence two roots, or two solutions. And that's done, an easy 1 mark. Do pause this video whenever you need to, remember that. Go back to the beginning, make sure you can answer every single question. It's a good recap of all your skills. Graph transformations and graph sketching should really be banker marks, but it's easy to forget the skills. Now let's have a look at these two bigger exam questions. It says we need to factorise this completely. Now we can use our chapter 7 skills and use a factor theorem, but you have to look and see there's an x in all these terms, so we can take x out. It's going to be x squared plus 10x plus 25. So we know that's x plus 5, x plus 5, and simplify that's x to the x plus 5 squared. So we're going to get a root at x equals 0 and a root at x equals minus 5, which is repeated. Sketch this curve, showing the coordinates of the points at which the curve cuts or touches the x-axis. So when it touches the x-axis, y equals 0, so I think we've done that. And we should check, so when x equals 0, we get 0 times 5 times 5, but that's still going to be 0, because 0 times 25. So that covers that. Let's just make a sketch of this graph. Minus 5, it's going to cross 0. This is the repeated root. You can see if you multiply the x's, it's going to be a positive cubic, so it's going to look like this. And the only way I can see this working is something like that. That is done. Alright, you can always substitute a value of minus 2 in here to see where this goes to double check. But that one is done. Now the point minus 3, 0 lies on this curve, where a is a constant. Find the two possible values of a. So this is really going to apply our thinking skills. What can we see? Doesn't this graph here look like what we have at the beginning? So that's y equals f of x here. This looks like f of x plus a. So that will help us unlock the question. So, what does this mean? Plus a in relation to graph transformations is going to affect the x, and that's going to move everything to the left by whatever a is, right? It says minus 3, 0. Well, let's say minus 3, 0 is here. Everything's moved to the left. So I imagine it could be something like that. That's minus 3. So what could a be? Well, if you're going to 0 to 3 here, this is going here to here. That's going left 3. So a can be 3. Now, what can we think? What if actually that's going this way, as in this graph is actually now like this. So from here to here, is going to the right 2. Right, so it's going to the right 2, then that means A could also equal minus 2. And hopefully that should make sense. You can see this is applying your skills, and that would catch quite a lot of people out. Very able students out as well. But now, I hope you know, and if a question like this comes up again, you can ace it. So you can see, like a question like this you could easily forget, so do have a look at this video in a few months time and see if you can still do it. That is the skill, and if you can remember, well done, you've put it into your long-term memory, you moved your short-term to your long-term, which is what we want. Okay, so courtesy as this equation here, using green pen for a change, looks like a reciprocal type graph. We don't know what K is. Sketch C, state an equation of the horizontal isotope. So all we need to think about is, well, what does 1 over x look like? Or anything over x? Something like this. Can you see this plus 1 is on the outside? So that's a translation up by plus 1. So we just need to re-sketch that. So the y isotope, which was x doesn't equal 0, that doesn't change. We know y doesn't equal 0, but that's moved up plus 1, so now it's going to be y doesn't equal 1. So let's do that as a dotted line. Label it y equals 1. And let's finish that off. It's only moved up, so this shifts up. That will suffice. This doesn't touch 1, so this is something like that. Let's extend that a bit, and that will be enough for your full marks. So can we label what that coordinate is? Well, does it ask you to do that? I'm not sure. It doesn't ask to say label the intercepts, but this is when y equals 0, right? So 0 equals k squared over x plus 1. So we're going to get minus 1 equals k squared over x times out by x. So we're going to get minus x equals k squared. Let's times that all by minus 1. So we're going to get x equals minus k squared. So just in case, that's probably minus k squared, right? Now let's look at the next part. The line L has equation y equals minus 2x plus 5. Show that the x coordinate of any point of intersection of L with C is given by a solution of this equation. So what does this mean? We've got 5 here. Just say this is 5, and we've got a line like this, possibly touching this once or twice. That's the representation, so you get a visual example. That's minus 2x plus 5. So what can we do? Right, well, if it's a point of intersection, equations must equal. So what do we need to do? Just set minus 2x plus 5 equal to k squared over x plus 1. Let's minus 1 from both sides. So we're going to get minus 2x plus 4 equals k squared over x. Let's multiply out by x on both sides. So we're going to get minus 2x squared plus 4 equals k squared. We're going to... Right, can you see in this equation we've got plus k squared here, so we might as well bring 4 and then minus 2x squared to the other side. So we're going to actually plus 2x squared and minus 4 to both sides. And you should be able to see we get 0 equals, and that's a 4. Well, if I times that by x, and let's just forget that's 4x minus 4x, so that's 2x squared plus, no not plus, minus 4x plus k squared, and we're done. And I'm just going to write that again in a different colour. So hopefully you can see at this stage we multiply both sides by x, so we're going to get minus 2x squared plus 4x equals k squared. We're moving all this to this side, so we're going to actually get k squared, but we're going to plus the 2x squared, so we're going to get 2x squared plus the k squared plus, not plus 4x, minus 4x equals 0, which is what they asked, which is actually 2x squared minus 4x plus k squared equals 0. So that should all make sense, and happy days, we've aced this.